All right, today we're looking at simplifying square roots. When we simplify a square root, I do not want you to get out a calculator and just type it in and give me an approximation of the decimal. The square root in front of us, the square root of 108, is an irrational number, which means if you get the decimal approximation, that decimal will go on and on forever and never repeat. That's not what I want. I want to maintain the complete number, and so I just want to make it smaller. All right, I'm going to give a parallel here in the same way that if I asked you to reduce a fraction 8/16, and I asked you to reduce that, you would say that is 1/2. All right, you didn't go down to a decimal 0.5. Okay, you kept it as 1/2. If I asked you to reduce 3/9, you would go down to 1/3. You're not going to give me the decimal 0.3 repeating. Now, the unique thing about those two fraction options there is that even if you did use the decimal, there's a way to write the decimal and keep it in its entirety. But when it comes to an irrational number, you can't write the entire decimal ever. It's not finite, like half would be 0.5. It's not repeating, like 1/3 would be 0.3 repeating. So I can actually write those in decimal form. If I were to write the square root of 108 in decimal form, it's an irrational decimal. It would go on and on forever. You could never actually write the whole thing. So I'm asking you to reduce, all right? So I'm going to keep these fractions up here because I'm going to use them. Because what I want you to notice is that in order to reduce a fraction, I divide it by the greatest common factor. All right, and that's how I got 1/2. Now, what if you didn't get the greatest common factor? What if you just divided by a common factor, like 4? Well, in that case, you would get another equivalent fraction, but it wouldn't be the smallest. And you'd have to go again. You'd have to do it again. Dividing by 2, give me 1/2. Because the smallest form is what I'm looking for. I want you to get all the way down to the most simplified version of that fraction. In square roots, it's the same thing. I want the most simplified version of that fraction. So we want to pull out the greatest number that will help us to make this smaller. So what helps us make square roots smaller? Well, what can you take the square root of? That's where this comes into play over here, perfect squares. You can take the square root of any perfect square number. This list, you don't have to memorize it. In your calculator, if you type into the y equals section, if you just type in x squared and then you go to your table, all right, it will give you a list of all of these numbers here. Now, when I look at this list and I'm trying to use one of these perfect square numbers to reduce this square root over here, I'm not going to use 1. 1, just like in a fraction over here, to reduce 8/16, 1 goes into it, but if I divided by 1, I didn't get anywhere. 1 doesn't help us reduce things. So I'm going to look on this list and look for the largest perfect square number that goes in to 108, and I'm going to rewrite the square root of 108. All right, so in this case here, if it's going into 108, it's got to be less than 108. So I'm going to draw a line right here because all of these are bigger than 108, so they're not going to work. And just take your calculator if you can't see it and just do 108 divided by 100. All right, and you'll get some decimal there. All right, 0. Some decimal, so that didn't work. All right, do 108 divided by 81. That didn't work. Do 108 divided by 64, and so on and so forth. If we keep doing that all the way down, we'll find that 108 divided by 36 is 3. That's the first time we get a whole number. It works. So that's the number I want right there, 36. Once you identify the largest perfect square factor, rewrite your square root of 108 as the square root of that perfect square number times the square root of its partner. In this case, 3. 36 times 3 is 108. Therefore, the square root of 36 times the square root of 3 is the square root of 108. Why did we pick 36? Well, it's a perfect square. That means I can take its square root. Square root of 36 is 6. I can't take the square root of 3, and so I'm done. As long as you get the greatest perfect square factor, you only have to do that once, just like we see over here. When you pull out the greatest common factor for fractions, it goes right to the answer right away. All right, so that's why we start at the highest possible number, why I started here at 100 and worked my way down until I found it. Let's take a look at the next one. So in this case, 32. What's the largest perfect square number that goes into 32? I'm going to draw my line right here. None of these will work because they're all greater than 32. So 25, does 32, can it be divided by 25? Nope. 32 divided by 16, that's 2. There it is. So I'll rewrite this as the square root of 16 times the square root of 2. Square root of 16 is 4. Square root of 2 I can't do without getting a decimal, and therefore that's my final answer. Let's do another one. Take a look at square root of 8. Square root of 8, well, that's easy. All right, none of these are going to work. But 4, 8 divided by 4 is 2, so 4 works. Rewrite that as the square root of 4 times the square root of 2. Square root of 4 is 2. I can't take the square root of 2, so I leave it as 2 root 2. Let's take a look at another one. What if I all of a sudden have a number out front? Well, if you have a number out front, nothing is going to change at this point. We're just going to do what we've always done. Keep that 10 right out front where it is. It's just being multiplied by our square root here, but I'm still going to break apart the square root into 2 numbers, one of which is the greatest perfect square factor. So I'm going to go to my list here, and technically you'd want to look further down the list, 448, but I'm just going to use this because I know none of those work. And here in this case, I'm looking at 512, all right, divided by 400. That doesn't work. And if I keep doing that all the way down, I'll find that the first one that actually works is 256. 512 divided by 256 is 2. Therefore, I'm going to write square root of 256 times square root of 2. And now I can reduce that. Let's go ahead and let's take the square root of 256. Square root of 256 is 16. And now what do I do with this negative 10 out front? Well, if the negative 10 is out front, we simply multiply that together. We're multiplying everything here. That's what this really means in the beginning when it's right next to each other. And negative 10 times 16 is negative 160 root 2. And that would be my final result. So when you got a number out front, it's only one extra step, which is to multiply that number with the other number out front at the end of the problem. Let's take a look at another one. 7 times square root of 75. So look for what goes into 75. Well, it's going to be less than 75, so these don't count. All right, 75 divided by 64 doesn't work. 75 divided by 49, nope. 75 divided by 36, nope. But 75 divided by 25 is 3. All right, 25 works. So let's rewrite this. 7 times square root of 25 times square root of 3. And then simplify your square root of 25, giving me 7 times 5. Root 3, that is 35 root 3. All right, let's take a look at the next step here. Now, you're going to see questions on the Keystone exam that look like this. They're now going to test your ability to understand the process by throwing in a variable here. Like 5 root 6x equals 15 root 6, find x. What value of x will make this true? To help me out, I'm actually going to move this down to the bottom, giving me 15 root 6 at the bottom, because I've been working down the page. If you look at this here, I started with my original up top, and I worked my way down to my final result. So I'm going to keep that consistent here. All right, and if I worked my way down, I would normally say 5 times 2 root numbers that multiply to get 6x, right? Well, in this case, what multiplies to get 6x? Well, it's x, our unknown, and 6. And then I know that I would do 5 times x would simplify out. I'd take the square root of x in some way to get a number that I don't know. All right, and this root 6, this just stays here the whole way down. So what I'm really asking myself is, what has to go right here to make this true? Well, in other words, what multiplies by 5 to get 15? Well, that answer is 3. 5 times 3 is 15. And you might think the answer is 3, but that's not x. Make it very clear. That is not x. Not x. Okay? That will be a multiple choice option. They will try to trap you. That is not it. It's just the step along the way. But if I need a 3 there, the question really comes down to this right here. And I'm going to change my color just to highlight this. It comes down to that. In other words, the square root of some number is 3. And I want to know, what is that number? That's our goal. Okay? Well, the square root of 9 is 3. Therefore, x equals 9 in this case. Okay, so be careful. They're going to try and trap you with that. by getting you to guess 3. Let's see another one. All right. Find x if 4 root 7x is equal to 36 root 7. So I'm going to bring 36 root 7 down here. I know that 4 times root x times root 7 would multiply to get there. Oops, sorry. Root 7 would multiply to get there. So 4 times some unknown number times root 7. And what do I need in this space right here? Well, 4 times 9 is 36. So again, the question is, the square root of x is equal to 9. 9 is not my answer. What has a square root of 9? Well, the square root of 81 is 9, so x equals 81. Again, be careful. 9 is not the value we're looking for. All right? And how could you verify this? This is something you do when you get to the final answer. If you're done, just type into your calculator the following. Type in 36 root 7 and hit equals. And then type in 4 root 7 times 9. All right? And hit equals. If you think 9's the answer there, all right, you'll see that it does not work. If I type that in, I'm just going to take a moment, type it in here. I get 36 root 7. I get 95.2. Oh. 95.2470. So I'm just going to say 247. All right. And if I type in 4 root 7 times 9, I get 31.749. Those are not the same. All right. So I know something's wrong. All right. So I'm going to go back here and just show you. Well, if that's the case, that's why 9 is not it. Remember, we said it was 81. If I plug in 81 here, and I actually go back and do that, I get 95.247. So to check your answer, you can plug the value of x right into the original and see if it indeed does equal the other side there. Use your calculator. Check your work. Don't submit an answer if it's not right. All right, let's take a look at the next one. All right, let's take a look at this one here. So again, I've got 50 root 8. And I want to know 10 times root x times root 8 gets me down to 50 root 8. So 10 times some unknown number times root 8 gets me there. Well, what times 10 is 50? 10 times 5 is 50. Therefore, the square root of x must equal 5. All right, because this becomes that. And we see 25 works. The square root of 25 is 5, so x must be 25. Let's check my answer now using what we just learned last time. All right, if I plug this into my calculator, I get, let me take a moment to plug that in, 141.4213, blah, 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 blah. All right, now I'm going to plug in 10 root, and it'll look like this in your calculator, 8 times 25. Make sure that you write it like that, okay? Otherwise, you're going to be getting the wrong thing there. Root 8 times 25. All right. And I get the same 141.421. It works out. That's how I know that it's right, because I can verify that this indeed is a true statement when x is 25. All right. Now, what about this case? Which value of x would allow you to simplify the square root of 21x? Well, in order to simplify something, we need a perfect square inside my square root. So once again, let's look at what we have here. We've really got 21. All right, our factors of 21 are 1, 3, 7, and 21. All right, so 1 I'm not going to look at. Like we said, 1, as we said up here, it doesn't do anything to simplify. But if I could find a partner with inside x that would partner up with either the 3, the 7, or the 21, we would get either 3 squared inside, or a 7 squared inside, or a 21 squared inside. All of those are perfect square numbers, because that's how you end up getting a perfect square, is by squaring a number, right? So in this case, I'm looking for a value of x that will share a factor with 21. Well, if we look down here, 7 is one of those right here. All right? It matches perfectly. Therefore, if I put 7 in there, you technically would have 21 is 3 times 7. And if I put 7 in for x, so this was the original 21, this is x. If I did that, I'm technically looking at this, which would technically be this, which would become 7 root 3. So you're looking for common factors when they're asking this one. What value of x would allow you to simplify this further? Let's take a look at another one. All right, what about this? 18, well, the factors of 18, square root of 18x here, I'm looking at. I've got 2, 3, 4, 6, 9, and 18. Can I find a value of x that shares a common factor with that? Well, 35, that's 1, 5, 7, 35. Nope. 5 is prime, so it's 1 and 5. Nope. 17 is prime, so it's 1 and 17. But 12, 1, 2, 3, 4, 6, all right, and 12. In fact, that shares 4 of the factors that we're looking at. So 12 would definitely allow us to simplify if we plug that in there. Just to explain why, again, if I'm looking at 18, I'm just going to pick 18 to be 3 times 6. And if I pick 12 to be 6 times 2, just picking out to have one common factor there, then I'm really looking at the square root of 3 times 36 times 2. And so I'm really looking at square root of 36 times the square root of 6. 3 times 2 gives me that 6 there. And that would reduce to 6 root 6. So that's how you know that it would actually work. You can actually simplify at that point. All right, let's take a look at one last one. Sorry this video is so long at this point. Again, I was covering a lot of things in it. Feel free if you're watching this video to skip to different parts. Saying that now at the end, a little ridiculous. Let's take a look here. What value of x would allow you to simplify the square root of 35x? Well, again, let's look at the factors. 1, 5, 7, and 35 go into 35. I'm not going to really consider 1 here. Of all the values down here, what one has a common factor with that? Well, looking at the very first one, 5 goes into 10 because our factors are 1, 2, 5, and 10. So 5 is a common factor. So if x is 10, we would be allowed to simplify that. And just to show why, 7 times 5 is 35. And 5 times 2 is 10. So if x was 10, this number inside would become 7 times 25 times 2, which is the same as the square root of 25 times the square root of 14. And that simplifies to 5 root 14. That's why it works. But again, you're looking for a common factor in order to have something simplify inside that square root.